See, in the last class, you people have gone through the case study on model view controller, right? As one of the architectural pattern, which is a very important thing that you will see in most of the application. This is the class and extension to that model view controller. Just have a look into that, right? I'm audible to all, Arpita?
Yes, sir.
Yeah. See, when do you go for model view controller? Why do you go for that? What all the components of that one? Okay, just have a look into that. See, you have a certain data set that is available called as a core data, and you wanted to, I mean, different people wanted to visualize this in different way. For example, here, now look at that on the screen. Okay, you have that is a data set available, right? Somebody wanted to view this as a pie chart. Somebody wanted to view it as a bar chart. Somebody wanted to view it as a okay, uh, the table spreadsheet and all, right? In that case, how to, what kind of mechanism, and what kind of architecture that you need to follow. And whenever I change, okay, the value in a pie chart, it should reflect in all other views, okay, that different people are from different place, they are viewing this core data. This is an objective of a model view controller, right? So model view controller, right, it has its own organization structure where it separates a repository from the view and allows all the views, okay, to view the data set in its own way and do the modification for the core data, which in turn will get reflected into all the observers. The views are all observers. Is that okay? A model view controller, Arpita, Ashish?
Yes, sir. Yeah.
Yeah, right. Now, when you look at this architecture, I mean, this is commonly used in almost every business. See, model view controller, okay, please prepare for that. Anyhow, in the next course, you will be studying that one, right? This is important from the placement perspective also, project perspective also, right? So the core part of this model view controller, I mean, principle, design principle is that, see, look at that. You can refer to this 1 minute. Okay, you can refer to this. See here, it divides an interactive application into three components, right? The model, the view, and the controller, right? Where the model act as a, okay, the core repository of data, right? View displays the information to the user the way they wanted to view it, and controller handles user input for every view separately. And one more important aspect of this model view controller is that any change, okay, done by any user through their view, it gets propagated to all the views, okay, and it will ensure that the consistency among all the views, right? It is not that at one place the view shows one data, other place the other data, no, right? Any change that happens everywhere, the same change you will find it, right? So this is the feature that you will look into, right? Now look into uh, the class diagram. Hope you all people know about the class diagram. Let's work on this. See, you have a model, right? Please look into that. Now I'll use the marker. 1 minute, I'll use a marker so that you can feel good about that while explaining, right? Right. Now look at this. See, you have a model. Now you find that in model view controller, the separation, right? You have model, view, and controller. The role of a model is to, right, hold all the core data, whatever it may be, and also the set of observer, all the observer, I mean all the views, they are connected to this model, which they wanted to view this data in different shape and form, right? And the functionality provided by this model is it allows the user, I mean view, to get attached to this, detached to this one, and a notify method, okay, will notify all the views, okay, if there are any changes in its repository, right? And also a get data and any other services, whatever that you can visualize. This is the functionality of the model. Are you okay with this? Are you okay with
Yes,
that?
sir.
Right. So hope okay, by this time you understand the class diagram, right? So the responsivity of the model, okay, that being captured and being modeled into this, put into this, okay, the class diagram called model, right? It collaborates with, right, view, and also it collaborates with the controller both, right? Now look at the view and the controller. When you wanted to design this, we go for an abstract class. Please recollect the use of an abstract class. Use of an abstract class is to ensure to put certain constraint on a design constraint or architectural constraint on all the classes you are going to derive from that, or in other words, the abstract class will put architectural constraint on the whole design. So what is the constraint here? So whatever the methods that it's going to provide here, that method, okay, all the inherited class must have it, right? Whatever it is. So update. Now look at the view. Now view, every view, right, is viewing its own model, right? So it has its own model reference. Okay, what model it is viewing. And every view has its own controller which allow the user to change the data, right? And okay, the methods like that one, initialize, okay, make controller, activate, display, and please look into that. One of the method that is mandatory for all is an update that is derived from the abstract class. So now we will see that one, how do this particular view functions, right? How do this particular model function? How do this controller, a separate controller for each, right, view, how do they function, and all these things we will see, right? Then you have a controller, one minute, like this, right? Then you have a controller, right? Right? It will get attached to its owner called my view. It gets attached to its model where any changes that the view do, a user of the view do, it can directly communicate to the model associated with its owner called view. So they store the reference of its owner in the form of the view and the model, and it has its own thing. When a controller is created, it will initialize itself by, okay, attaching, storing a reference to its model, to its, okay, view, right? Then it will handle the event and it will update, right? So this is how the overall a class diagram is written, and a model has, okay, one or more observer, right? And view and controller are inherited from the observer, right? They have their same behavior, and every view has its own equivalent, okay, its own controller which allow the user to modify. Now let's look into the next one, right? See, we use, okay, what is called CRC. It is being referred as a class responsibility and collaborators. Name of the, now functionality of this, each class we will see in the form of CRC. CRC stands for class responsibilities and collaborators, right? Now let's look into the a class called model, right? What all the responsibility of the model? Provide a core functionality, register, unregister, and notify, right? These are the functionality, right? Very abstract, very professionally written. Then with whom it collaborates? It collaborates with the view as well as controller associated with that, whoever is registered with the model, right? Now let's look into the functionality of the view. The role of the view is to, right, display the information in its own way. It could be pie chart, bar diagram, line diagram, whatever that is, table, whatever that is there. And it has to implement the update procedure. How exactly it's going to update itself. Every view, right, has its own different update mechanisms, right? And it has a mechanism to retrieve the data from the model and update itself, right? And it will create and initialize its associated controller, and it collaborates with its controller and its model where it is associated with that, right? This is the functionality of the class. Every class is described using what is called a CRC model, class responsibilities and collaborator model, right? Now let me get into the next one, right? A controller. Now let's look into the controller, right? So the controller, the purpose of the controller associated with every model, right? Sorry, every view is to accept the user input as an event, translate that event to the service request for the model, right? Right? Then implement the update procedure if required, right? Update procedure in the sense how to every view update, though it is modifying certain thing, the view doesn't update itself. It has to be routed through the model only, so that there is a consistency among the several views which exist and associated with the same model. We will see this. And its collaborators are view, its owner view, and the view where it is associated, I mean model where the view is associated model, right? So these are the collaborators. This is how the classes are being described using CRC diagram, right? Hope you all clear about the functionality of model view controller, right? Arpita, is it okay? Arpita,
Yes, sir.
right, good, that's good. Right, now let's look into how do they function. The functionality of the model view controller, okay, usually we explain by a sequence diagram. Sequence diagram is a very popular tool in explaining how do the object interact with each other, right? And you know the details of this already we have gone through once, right? And again you will be seeing in different courses also, right? See here, main program is an object, a model is another object, right? The view is another object, right? This vertical box, whatever you put it here, vertical line, they are called a lifeline, right? That means, I mean, the box, whatever you see, some author, they indicate like this, it indicates that the lifetime of that particular view. That means it gets created. Now let's look at the blue color one. It gets created here, and the object is getting created here, and the object get terminated here. After this point, the object is no longer exist. Is it okay, Arpita?
Yes, sir. Yes.
Yeah. Now let's look into that, how to this particular thing interact with each other. When the main program start executing, first it creates a model. Are you getting this? Right? It creates a model, right? And right, 1 minute, I'll remove this all so that you can understand. Now I'll create a fresh one, right? It creates a model, right? Then it creates, right, okay, the model, then it creates its associated view, right? Then it creates a view, right? Then this particular model get attached to the view, right? Model is created once and every time, right? When a view is created, the model reference of this particular model is passed as a parameter to the view whenever you are creating a view, and okay, that model reference get attached to the view. Then what view will do is, okay, by taking the reference of the model, it will attach itself to the model, its reference. So the model knows, right? Model knows, it will call attach method of the model and gives its reference here, so that model stores the which view is getting attached, right? Are you getting it? Then view, what it does, okay, it creates its own, okay, controller, right? Controller gets created, right? And the view will initialize the controller by giving the object reference of model and itself, okay, during the initialization. So that controller takes who is a model with which its owner called view is getting attached. It takes that model reference and attach itself, okay, to the model with whom the view is getting attached. Are you getting it? This is how the overall initialization of the view is taking place. And sequence diagram is one of the popular tool. Just a minute. Sir, one ನಿಮಿಷ ನಂದು. Okay, I'm back here, right? I'm back here, right? This is how the communication takes place. See, whenever you wanted to explain about the working of particular scenario and all, the sequence diagram is the best example. Okay, you can use to demonstrate how the working takes place, right? Are you clear about that, right? So let me get into the next one. The explanation are given here. How do that interaction takes place? Look at the how professionally the statements have been written, right? I'll not read this. I'll leave it to you so that you can go through this. Now let's look into that. How do the event handled by the controller and modification takes place? Any change done by the controller for a particular view get reflected in all views. Okay, let's get into this. A controller of a particular view, right? Whenever you modify a table or a pie chart or a bar chart, there is a method called handle event, right? It could be okay, keyboard handling event or mouse dragging event, whatever that is there. Once it receives that one, what it does, okay, it calls the service of the model, any change, right? Right? Then this model will call the notify, right? Please look into that. A controller has a change value, a change data is available with the controller, right? Now see that one, it will inform the model that there is a change in the value. Then model in turn notifies all the views that please update, but it doesn't provide a data, right? Now what happens is the view, right, it calls is it's a display routine. You display. Then the display routine in turn, okay, calls a model, get me the data, right? Are you getting this? Then what it does, get me the data. At the same time, right, the model inform that particular view or the controller which has modified that. It will say that update. Are you getting this? Then this the one which is modified controller and also all the views they get it data from the okay model, right? They also get it. It doesn't modify the data whatever that is available with it itself, because there may be possibility that the controller, the source which has modified, it has modified the data, it will update and show in the view, and some of the views they fail. In that case, you find that inconsistency among the different views. So though the controller has modified the data, it doesn't reflect in its own view. It will inform it to the model. Model has its own changed value. Then all the views, right, including a controller, has to get the data from model, right, and update itself. All the views, including the view which has modified the data, this also. So thereby, it will ensure the consistency among the different views in case of any failure. Are you getting it? Right? Are you clear about this? Are you clear about this?
Yes, sir.
Right. Please go through this, and I have added certain explanation for this also. You can go through. Right? Right. And I will not cover this. This is the code skeleton. This is the code skeleton. How do you write it in one programming language? Right. So don't expect that Java programming language all the time. Right. Any programming language, pseudocode or anything that is given, you should be in the position to visualize this, visualize and then code it. Let me take you to the one such example. Right. Consider the class model. How do you write? It's a pseudocode, like it doesn't have everything. Right. Now look at that. It has attach method, pass any observer, that means view as a reference, it will get attached to itself by saying registry, that is the registry dot add as. Right? Hope by this time you can understand what exactly is the meaning of that. Registry is an object where it stores everything. Right? Registry dot add this is. And similarly detach, right? You can visualize registry dot remove. Right? Registry is the repository object where it can store. Got it? Right? So when you look at this registry, probably you can go to the class diagram and see, right? Right? Here, attach, detach, and here set of observers, right? Set of observers and core data. Set of observers, it gets attached to this, right? The pseudocode I'm talking, it's a beyond the syllabus. Please try to look into that. Okay, we are in model, right? Then it has its own notify mechanism, which will notify all the observers registered with that if there is any change. Now look at the registry. Okay, registry is a set. Registry is a set of the type observer. Are you getting it? So this is a pseudocode. Okay, don't try to look into that. How does it functions and all? You have to equivalent of that one. You have to implement it. Right? This is a model. How does it works? Now let's look into the observer. Right? Every observer, right? It's a common to all. It has one virtual method. In C++, you have virtual method update. Just a minute, I have got a call. So I'm back here, right? I'm audible to you, Arpita?
Yes, sir, you are
Yeah, right.
audible.
Yeah. The observer is an abstract class where it has only update method. There are no implementation. So thereby, it will put a constraint on all inherited things. That one, every view must implement update method in its own way. Updating table view is different. Updating pie view is different. Updating pie chart view is different. Updating bar chart view is different. So update is different for different objects. But you are putting a constraint that tomorrow, if at all you create one more view, that also must implement update. This is the beauty of using an abstract class, right? Right. Then I'll get into the different part of the methods used in model, right? Let's look into notify. How to implement a notify, right? So you have a iterator, right? Okay, you pass the registry, then go through that iterator, right? And every view registered in the registry, what you do is call its update method, because you have a reference. Your reference to that particular view. Okay, reference. This is the iterator. It is something like a bag collection, right? In that there are different objects are there. Go through that. It is something like an array, right? Then the you get the current one, whatever that is there, right? The iterator, how it is being implemented. Then the object reference, whatever you get, call its update method. Call its update method, right? This how a notification takes place. Please look into that. Now you have to visualize how exactly the code is being written for the design that's given to you. It is a pseudocode. It is an abstract kind of things, right? Right? How professionally it's being written, look into that, right? Now let me take you to the observer, right? Observer, right? See, observer, right, has, the class view, right? It's derived class view is derived from the observer. Got it? It's a C++, code similar to that, right? It has a constructor wherein the model reference is being put into that one. This is being created by the main program. Okay, you can refer a sequence diagram, right? So, okay, my model, right? My model is a local variable which keeps the reference of the model given to that, so that the view to which model it is associated is being stored as a local variable in every view. Are you getting it? Right? Then you have a my controller object is being created, right? And look at that, my model, whatever the reference you have it, and you are attaching yourself to that particular model, so that model stores this particular view in its registry. It is to be read in that way, right? Similarly, you have a like a constructor, you have a destructor, right? So you are detaching yourself, okay, from the model, right? Then update routine, what it does, this dot draw, every update routine it will draw itself. Got it? It has the initialization and the draw method, whatever that is there, it will draw about that, right? Get model will return the model, okay, with which it is being attached. Get controller returns a my controller reference, right? And you have a variable called my model, my controller, they are the pointer to the model and controller. Are you getting this? Right? So this is the pseudo code of a particular view, right? It doesn't work on its own. It gives an idea how it is being scripted, right? Then a particular view, okay, bar chart, right? Right now look at that. Okay, you have a class view. You have taken particular instance of that. Say bar chart is derived from the this view. Then bar chart view, that constructor within that pass reference and view all the things whatever that is there, right? Get into that. It has its own draw method. So this is how the bar chart is being seen, right? This is how the bar chart is being seen. Similarly, pie chart like this you can get into. Are you getting this? Right? So, similarly, you can have a controller, it's a code. Controller again is derived from the observer, right? Handle event is there, right? Then a constructor with the same name, controller, it gets attached with a view, right? Understood? Right? My view, right, is a reference local variable where this view is stored. My model, right, it gets a model to which the view is attached, right? Then it will, okay, controller also it will attach itself to that model with which its view is being attached. So you have a destructor, it detach itself from the model, right? There's update routine, right? And the protected variables are, say, my model and my view. Are you getting this? So please try to, okay, if you wanted to grow in terms of programming for the given design, this pseudo code, if you can visualize, that will be of nice. And if anybody implement a model view controller, okay, really without using any tool and all, fine. I will openly announce that one, they will get 10 out of 10 for a CTA, straightway. And they have to demonstrate this, right? I'll put this as one of the assignment. People can make, okay, an attempt on this, right? Make an attempt, right? But I will, it is not mandatory that you need to do that, right? There is one more course called Object Oriented Analysis and Design. We'll study in the next semester. Okay, there we'll try to make this as a mandatory, not now. So what is that we are doing? What we are doing is, okay, we are looking into one of the architecture. See, this architecture is different, framework is different. The model is different, or the pattern is different, right? And our framework is different. When we talk about the pattern, they're all generic in nature. It doesn't speak about any particular business. Whereas a framework is a colony by itself. Okay, it has its own. Okay, it is specific to okay, particular domain. For example, Java imaging framework, okay, is available. That it will give a set of libraries, set of programming environment and all those things. They are specific to particular domain. Framework will be always specific to particular domain. Imaging, brain signals analysis, okay, audio analysis related things, right? NLP framework related things, natural language processing framework and all. So they have got a programming environment. They work in a specific, okay, the domain. Whereas when you talk about the pattern, they're all generic in nature. They're all generic in nature. It can be used in any domain in all. And when we talk about the architecture, right, patterns are nothing but okay, solution, generic solution for frequently occurring problem, right? And tomorrow, if at all you are developing something in a particular domain, right, you can replace all these things by a specific, okay, domain specific languages and all. So are you getting this? Domain specific language can be embedded into all these things, right? Is it clear? I wanted each one of you do little brainstorming and try to visualize how the pseudocode has been written for this particular class diagram, right? In this class diagram, this is the inheritance. Observer is a generic, okay, an abstract class. View is to be inherited from the observer, right? Are you getting it? Right? Then you can create a particular instance of a view called, say, bar chart, particular instance of, okay, the view called pie chart, particular instance of the view called table. Are you getting this? See, a cricket, you know, the cricket score, you can see it in the form of a table also. You can see it in the form of a continuous text, scrolling text also. That is a different view, right? But the core data is same. How do you visualize that core data by different view, right? Okay, is the best example can you can see in the form of the model view controller. And please don't think that when we talk about the model view controller, right, these objects, these classes and all, they all stay together at one place. Don't think that. They can be distributed in different servers. Of course, view has to be there in different client machines only, right? And model, right, is in at some other place, naturally. Are you getting this? So the very objective of the model view controller is that it allows this, okay, the different views or different user to view the core data in different way and yet do the modification and ensuring that, right, any modification that is being done at one view, okay, propagated everywhere so that there is a consistency of the data among the different views that whatever you have it. Are you okay with this?
Yes, sir.
Right. Any question? This is an extension core design perspective of the explanation, whatever that you have seen yesterday. Yesterday you have seen the, okay, the maybe what are the tools available, what is the generic use of model view controller and all. This specific to with reference to the class diagram design. Is it okay? And this particular explanation I have given it in my Google class. I wanted you have to go through that. And today, every business, every application, people talk about the separations, policy and mechanism separation. We say, right? Why do you do that? Maintenance becomes simple, right? Now look at that. Okay, when you maintenance in the sense, okay, please recollect. Okay, adaptive maintenance and corrective maintenance, right? For example, adaptive maintenance. Okay, tomorrow Govind will come and say that one, I want to have a different views on this set of data. Okay, create that one, simply plug in here. It works very easily. You can absorb that change, adaptive change, adapt in the sense new things you are going to adapt that one, right? Very easily here, right? So you need not have to, okay, disturb the entire, okay, design or coding and all. It is a modular approach, right? That's what we say that one in operating system we say policy and mechanisms, right? They are all separation. That's how the Java virtual machine JDK you can, okay, visualize, or microkernel you can visualize, which is the core principles of any operating system implementation, right? Now in this case, similarly, extrapolating that one, what you are doing, what we are doing here is, okay, entire design instead of one clumsy class like this one, what we are doing is we are dividing that into the interactive application into three components: model, view, and controller, so that reading, understanding, designing, maintenance of this design, right, everything's become simple, right? So that's what is the cornerstone of any new application design principles today. And model view controller is almost used everywhere today in every application that you find. Go in, am I right? Right. So you should understand this particular thing. From placement perspective also, this is a very important thing. Say when you are explaining about your project, if at all you are going for such application, you can simply say that one, okay, the architecture used in my application, my project is model view controller, and assume that Govind is a, okay, reviewer there, okay, he finds it very interesting. Oh, model view controller, you are using it, explain about that. That's how you can be very professional in projecting and presenting, okay, presenting your projects. Govind, am I right? Right? Whatever that you learn in software engineering, you need to demonstrate. Otherwise, my colleague Govind, Professor Govind, will ask you that, who is that fellow taught you software engineering? And when you say, probably you may not say my name, or you may say my name with hesitation, then Govind will think that, oh, what kind of nonsense thing have been taught in software engineering, right? Don't give a scope for that. Anything and everything. In fact, yesterday in the Informatica, right, in the interview, okay, people asked, okay, in last round, Govind, right, how, what are the different ways of creating a files in Unix? Look at that. Name 25 commands in Unix, right? People, okay, they were asking about a lot of things, any corner, including Oracle architecture, right? Are you getting it? So from which corner you get, you don't know, right? Name 25 Unix commands. That was there yesterday, right? Different ways of creating files, right? Touch command you use to create files, am I right? Empty file. People were asking about that, and people were asking about that one, okay, how do you delete a file in Unix which is similar to the message what you get it on the in Windows operating system? Are you sure that you wanted to delete, okay, kind of things, right? Okay, I think if I'm right, because I don't use regularly, Govind then to tell me that rm I minus I option, how do, I mean, which, from which corner you get for placement, who knows it, right? It is not necessary that everything you have to tell, but when you study completely so that you recollect during your placement preparation. So what I'm telling is model view controller is also one such similar thing. Please prepare it. Don't, okay, argue with me, or with a complaining attitude talk with me. Model view control is not there in software engineering. Why did you take that one? Because we were talking about the architecture, I need to correlate with what is the trending thing in the market and all, right? Hope Govind will agree. He's sitting in my room, right? He will agree with that. Govind, you can disagree also with my statement. So please go through that. We are all studying for placement perspective to make better professional career, not for examination. Examination is by default automatically. So now session is getting closing, right? Getting closed now, closing now. So allow me to stop this meeting, end this meeting, right? Arpita, am I right? Whatever I said, it's convincing to you all people.
Yes, sir. Yes, it is.
Please go through this video also. I'll upload, and material I've placed already in the Google class. Please refer it. If anything you wanted to more, right, please let me know. Okay, I'll tell you. Right? Right.
Yes, sir.
Okay. Is it okay? What the extension, whatever that you have gone through yesterday, for that this extension we have given to you. Hmm? I will end the meeting.
Yes, sir.
I will end the meeting, Arpita.
Thank you, sir.